Welcome, dear students. We can today discuss about vectors. The problems on vectors or your unit model examination 4. It contains vectors, 3D and linear programming. So I hope that you know the equations inside down what we used in our plus 2 level 6 problems. So here vector is there. So having some dot product, cross product. I just explained that all when you want to discuss any theory content inside that. Okay. So we can start initially our first problem. Actually, a very simple problem is there. The distance between the points A and B with the position vectors I minus j plus 2i plus j plus 2k. Here, the way is this. There are two different points. A and B is there. A and B. Whose position vectors are there. I minus j plus 0. Okay, there is no z point is here. And here it is 2i plus j plus 2k. You want to find the distance. This distance is there. You know, position vector means if there is a point from origin is there, we can identify this is a vector and here also a vector. That means if it is O, you have that vector OA. Vector OA is equal to I minus j and vector OB is equal to 2i plus j plus 2k. So you want to find what is AB. This is the vector AB. AB is equal to OB minus OA is there. So you can, it is 2i plus j plus 2k minus our I minus j is there. It is equal to I plus 2j plus 2k is vector AB. Then this is actually a new vector. We can mark this one as AB. So what about the distance between the distance between is the modulus of that vector AB? This will be square root of 1 plus 4 plus 4 is equal to 3. So if two position vectors are given, then OB minus OA will give the distance between the distance vector. Then you can find the magnitude as what? Root of a square plus b square plus c square will provide option 4. It's a very simple problem. Now, question number 2. Equation of the plane through the point 2, 1, minus 1 and minus 1, 3, 4 and perpendicular to the plane 2x minus 2y plus 4 is equal to 0 is given by. Here 2 points are given and that plane is perpendicular to the given plane. That means if you know the direction ratios of the required plane, they are what? A, B, C. Suppose A, B, C be the direction ratio of normal of a plane. Then equation of any plane through a point, this one of the point I selected here as a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0 is the equation of any plane through x1, y1, z1, a point, and whose directions of normals are ABC. Here, you choose initially x1, y1, z1 as this point, x1, y1, z1. Therefore, a into x minus 2 plus b into y minus 1 plus c into z plus 1 be the equation of a plane. You want to find that equation of a plane which passes through the next point minus 1, 3, 4 and perpendicular to that plane. So here, it's a very simple situation is there. You can find what is A, B and C by introduce the point given. It passes through the point minus 1, 3, 4. So this will provide you A into minus 1 minus 2 plus B into 3 minus 1 plus C into 4 plus 1 is equal to 0. Because of the equation the plane passes through the second point will provide a new equation involving A, B and C. So you got that minus 3A plus 2B plus 5C is equal to 0. Keep it equation number 2. You need to find one more equation because that equation 1 perpendicular to x minus 2y plus 4 is equal to 0. So you know the direction ratios of this plane is 1, minus 2, 4. The coefficient of x, y and z are a direction ratio of any plane. And from equation 1, you know ABC are the direction ratios of the normals of the required plane ABC. And these two are perpendicular. That means the normals definitely are mutually perpendicular. That means first one be referred as N1 and this is N2. Then definitely N1 dot N2 is equal to 0 because they are perpendicular. Dot product should be 0. Therefore, A into 1 plus B into minus 2 plus C into 4 is equal to 0. That is A minus 2B plus 4C is equal to 0. Equation number 3. So you have two more equations. This, one, this, and here that. So at a glance you can observe them. Here it is 2B and here it is minus 2B. So you just add to avoid that B. You want to solve it. So I put them what 2 plus 3. That we can identify initially by minus 3A plus 2B plus 5C is equal to 0 is our equation number 2. And add this, you got that minus 2A plus 0 plus 9C is equal to 0. That implies 2A is equal to 9C. So to find that value, it is better you can keep. Let us C is equal to some 2K or 2 lambda. Therefore, 2A is equal to 9 into 2 lambda. Therefore, A is equal to 9 lambda. Therefore, A is equal to 9 lambda. So you got that A is there. Now you can find what is B for keeping this equation here. For equation 2 or 3 implies. You can put the obtained values of A. A is 9 lambda and minus 2B is there. And 4C, that is equal to 4 into 2, that is 8 lambda is equal to 0. Or B, 2B is equal to 17 lambda. Or B is equal to 17 by 2 lambda. So you have one more variable there. It is equal to B and that is equal to 17 by 2 lambda. So you have three variables. And our first equation. What is our first equation? You know, first equation is equation number 1 is this is our equation 1. So we can replace that A as 9 lambda into x minus 2 plus B is 17 by 2 lambda into y minus 1 plus 2 lambda into x z plus 1 is equal to 0 with the equation, this equation. This we can properly replace by that too. And now you can dividing by lambda implies that this all lambda get cancelled and multiplying by 2 you got that 18 into x minus 2 plus 17 into y minus 1 plus 4 into z plus 1 is equal to 0, expanding 18x minus 36 plus 17y minus 17 plus 4z plus 4 is equal to 0. That is 18x plus 17y plus 4z. And this minus 36, so you got at minus 49 is equal to 0. So 18x plus 17y plus 4z is equal to 49 is the answer or the required plane. So the option 1 is that. So we can easily find it. So listen, first of all, you should keep this formula. Equation of a plane is A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0 because of any plane passes through x1, y1, z1 and whose direction ratios are ABC. Now if it is perpendicular to a plane, then this A, B, C, ABC are exactly normal. So that normal is perpendicular to the next normal. So we can make one more equation in terms of ABC. So you can solve that by keeping any one of them be lambda, the multiplier of lambda, and solve for other two variable. And finally, you come back to the initial equations, replacing with the ABC along with the multiples of lambda. Dividing by lambda will out the entire lambda from the equation. And after we can expanding and simplifying it will give the required plane. Okay. Now I come to the next problem. Question number 3. Question number 3, I shall read to you. Find the value of k so that x minus 1 by minus 3 is equal to, this is our equation. the value of k so that the lines x minus 1 by minus 3 equal to y minus 2 by 2k equal to z minus 3 by 2 and x minus 1 y minus y 3k y minus 5 by 1 and z minus 1 are perpendicular to each other. Find the value of k so that these lines are perpendicular to each other. Two lines are perpendicular to each other. You know the direction ratio of the line. This first line can be written as in the form x or simply r bar is equal to some a bar plus lambda b1 bar. And second one is r bar is equal to a2 bar plus lambda b2 bar. So the direction of the first line is actually b1 bar and that of second line is b2 bar. Because of they are mutually perpendicular, definitely b1 cross b2 or b1 dot b2 equals 0. That means b1 bar dot b2 bar is equal to 0. This is the condition for two perpendicular lines. These lines are perpendicular. Then first b1 bar is equal to minus 3i plus 2kj plus 2k. This k is actually not like this, it's a vector like this. And second one is again b2 bar is equal to 3ki this plus j and minus 5k. While you mark this one, you keep the sign along with the x minus 1, y minus 2, z minus 3 should be there. X, the coefficient should be 1. That is definitely positive and keep that should be 1, y should be 1 and z should be 1. And here also, if it is a very different pattern to multiply with the 2x minus 1, then you should keep the 2 out. And the corresponding change may happen in the denominator, then only we can proceed with the b1 and b2. Here, b1, b2 is equal to 0 means you can find the for b1 bar dot b2 bar is equal to minus 9k plus 2k minus 10 is equal to 0. Therefore, you could that is equal to minus 7k minus 10 is equal to 0 or simply k is equal to minus 10 by 7. So minus 10 by 7 is a simple value. So option 1 be the correct answer for that problem. Now question number 4. The equation of a sphere whose center is 2 minus 3, 4 and radius is 5. You know, the equation of a sphere is x minus x1 the whole square plus y minus y1 the whole square plus z minus z1 the whole square is equal to 5 square. Or simply, if it is radius is r square. So, where r is the radius of the sphere and x1, y1, z1 be the center. So, if you have the center and radius, we can easily write down the equation. Here it is equal to x minus 2 the whole square plus y plus 3 the whole square plus z minus 4 the whole square is equal to 5 square. So it is equal to x square minus 4x plus 4 plus y square plus 6y plus 9 plus z square minus 8z plus 16 is equal to 25. So you know 5 and 25 will get cancelled from here and finally it is written like this. It is equal to x square plus y square plus z square minus 4x plus 6y minus 8z plus 4 is equal to 0, which should be given in our second option, x square plus y square plus z square minus 4x plus 6y minus 8z plus 4 equal to 0. So direct formula we are able to applying there. The sphere is equation of sphere. This is a three-dimensional geometry problem. Now, question number 5. The angle between the planes 2x minus y plus z equals 6 and x plus y plus 2 z equals 0. To find the angle between two planes a1x plus b1y plus c1z is equal to d1 and a2x plus b2y plus c2z is equal to d2. You just find the normals. N1 bar is equal to a1i plus b1j plus c1k. Here it is n1 bar. This equation has 2i minus j plus k. And n2 bar is equal to a2i plus b2j plus c2k. Here it is equal to I plus j plus 2k. Now, angle between the planes is angle between the normals. angle between the planes is the angle between the normals. Therefore, cos theta, if theta be the angle, then that should be angle between the normals n1 bar dot n2 bar divided by mod n1 bar mod n2 bar. So it is equal to 2i minus j plus k dot I plus j plus 2k all divided by square root of 4 plus 1 plus 1 into square root of 1 plus 1 plus 4. So it is equal to 2 times 2, that minus 1 plus 2 divided by root 6 into root 6, that's equal to 3 divided by 6 is 1 by 2. Therefore, cos theta is equal to 1 by 2 implies theta is equal to pi by 3. You know the answer cos 60 is 1 by 2. So when you find that a bar dot b bar by mod a bar mod b bar will provide you 1 by 2. So correspondingly the angle theta is a pi by 3. So angle between the normal is a pi by 3. So definitely angle between the plane also pi by 3. So option 3 is the correct answer for question number 5. Now question number 6. The radius of the sphere. You want to find the radius of the sphere. X square plus y square plus z square equal 12x plus 4y plus 3z. So you can choose to left side as in the form x square minus 12x plus y square minus 4y plus z square minus 3z is equal to 0. I choose that all right values to left side. Now combination of square. This will be x minus 6 the whole square minus 36. Here y minus 2 the whole square minus 4. Plus here z minus 3 by 2 whole square minus 9 by 4 equal to 0. So the equation becomes in the form x minus 6 whole square plus y minus 2 the whole square plus z minus 3 by 2 the whole square is equal to 36 plus 4 plus 9 by 4. So 40 plus 9 by 4. So 169 by 4. So this is r squared. Your requirement, what is the radius of the sphere? So r is equal to root of 169 by 4 is 13 by 2. So converting as the perfect square form, we finally come back to the equation as x minus x1 the whole square plus y minus 7 the whole square plus z minus 7 the whole square is equal to r square. So automatically you have to find what's the value for r, and that value for r is exactly 13 by 2 here. Option 1 is the correct answer for question number 6. Now question number 7. Inside 7 the problem, the value of lambda to be identified, which is 1 minus x by 3, y minus 2 by 2 lambda is equal to z minus 3 by 2. And x minus 1 by 3 lambda, y minus 1 by 1 and 6 minus z by 7 are perpendicular to each other. So first of all, you convert the question in a proper way by shifting the sign. Here you can put them as what? X minus 1 by minus 3. Here it is given as 3, but here it is x minus 1. So whenever you are reversing to find the exact order, you should keep the sign, and that will provide you x minus 1 by minus 3, which is equal to y minus 2 divided by 2 lambda and z minus 3 divided by 2. This implies our b1 bar is equal to minus 3, 2 lambda and 2. These are the direction ratio of the line which is parallel to this vector b1 bar. And at the same time, second equation, this is x minus 1 by 3 lambda is equal to y minus 1 by 1. And that is also reversed. So we can put them as what? Z minus 6 by minus 7. So this implies that b1 bar is equal to 3 lambda 1 and minus 7. Here it is minus 7. When you shift them, it should be minus 7. This 7 become minus 7. Now, they are perpendicular to each other. So, how to conclude this? If these two are perpendicular, b1 bar dot b2 bar is equal to 0. Therefore, minus 3 times 3 lambda is minus 9 lambda plus 2 lambda minus 14 is equal to 0. Or minus 7 lambda is equal to 14, or lambda is equal to minus 2. So you are aimed to find what is lambda, which is given as minus 2. So option 2 is the correct answer for that problem. Option 2 is correct answer. Now, question number 8. A unit vector in the direction of the vector A bar is equal to 2i minus 3j plus 6k. You know, A cap is equal to A bar by mod A bar. So here A bar is equal to 2i minus 3j plus 6k. Therefore, mod A bar is equal to square root of 4 plus 9 plus 36 is equal to 7. So, this will be 2i minus 3j plus 6k divided by 7, or you got the answer as 2 by 7i minus 3 by 7j. It is equal to 2 by 7i minus 3 by 7j plus 6 by 7k. So, which is given as our third option. So, it was a very simple problem. So, we can find third option with the correct answer for that question. Now, you come to question number 9 as the direction cosines of the vector A bar. You know, direction cosines are actually, A bar is equal to, if A bar is equal to A1i plus A2j plus A3k, then coefficients of ijk correspond to unit vector be referred as a direction ratio. That may be positive or negative. So, if you are identifying the direction ratio, you know, this is equal to A1 divided by mod A bar and A2 divided by mod A bar and A3 divided by mod A bar is actually direction ratio cosines of that. So, you just find a unit vector and write down the answer. You know, you can keep them directly plus, all of them are put with the plus sign, or you multiply all with the minus sign is also maybe the direction ratio. That is only the situation. So, here, you know that A bar is given as A bar is equal to minus 2i plus j minus 5k. Therefore, mod A bar is equal to square root of 4 plus 1 plus 25. So, root 30. Therefore, minus 2 by root 30, comma, 1 by root 30, comma, minus 5 by root 30 is the direction cosines of the given vector. It will also be written as in the form 2 by root 30 minus 1 by root 30 and 5 by root 30 is also a direction which will be given. That should be, we can accept it here. So, minus the first one be the option 4. No more is given. So, these are direction cosines. If you want to find the direction ratios, exactly minus 2, 1 and minus 5 be referred as my direction ratios. So, direction cosines will identified by taking that direction ratio along with the division by magnitude of the vector. Then you can find the direction ratios correspond to its unit vector. So, direction cosines are exactly direction ratios of the unit vector. So, to find the unit vector, you need to dividing with the magnitude of the given vector. But the only situation is that when you're dividing them, if A1, A2, A3 be the direction ratios, then plus or minus of all will be referred. Okay. So, here the first or option 4 be the correct answer for this question. Now, if 1, 2, minus 3 and B, minus 1, minus 2, 1 are endpoints of the vector AB, then the direction cosines of vector AB. So, initially, you know, vector OA, our initial position vector is I plus 2j minus 3k, and OB is equal to minus I minus 2j plus k. So, vector AB is vector OB minus vector OA. So, we can subtract this minus I minus 2j plus k minus of I plus 2j minus 3k, which is equal to minus I minus, that is minus 2I minus 4j plus 4k. So, this is vector AB. So, you just find the magnitude of vector AB to find the direction cosine. So, this root of 4 plus 16 plus 16, that's equal to again 6. So, 1 by 6 of that total value. So, it is equal to minus 2 by 6, minus 4 by 6 and 4 by 6. Or it will be written as minus 1 by 3, minus 2 by 3 and 2 by 3 is the direction ratios. Otherwise, we can kept it as in the form 1 by 3, 2 by 3 and minus 2 by 3. This also be referred as direction ratios of a given problem. So our question is there minus 1 by the first. This will be given as third option. Sometimes it is given here. This also be the direction ratio. So you observe them where it happened. So just you find what is A, B vector AB and find the magnitude and dividing with the ijk value. Then you can find the coefficients of ijk will guarantee your required direction cosines. Now our next problem is the vector which makes the angle alpha, beta, gamma with x axis, y axis and z axis respectively. Then the value of sine square alpha plus cos square alpha, sine square beta plus sine square beta. You know, if alpha, beta, gamma are direction angles, they are known as direction angles. Then the cos values, cos alpha, cos beta, cos gamma are direction cosines. Now you know that if x bar or r bar is equal to there, you know, r bar is equal to some xi plus yj plus zk, then cos alpha is equal to x by mod r and cos beta is equal to y by mod r and cos gamma is equal to z by mod r. So this will be referred as L, M and N. So this will be L and here it is equal to M and that should be N. So you know L square plus M square plus N square, that's equal to x square by r square plus y square by r square plus z square by r square, which will be x square plus y square plus z square divided by r square. So this L square plus M square plus N square, they are direction cosines. So cos square alpha plus cos square beta plus cos square gamma is equal to this value. You know, this is actually r square get cancelled, got 1. So that is very interesting. You know, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Equation number 1. You can keep in your mind. So if alpha, beta, gamma are direction angles, then corresponding cos square alpha plus cos square beta plus cos square gamma is 1. But your requirement is not exactly cos square alpha, cos square beta. It is actually what? Your requirement is what is sine square alpha plus sine square beta plus sine square gamma. You can keep this value is equal to some k and kept equation number 2. Now simply add this all. Your requirement is what is the value for k. So value for k means sine square alpha plus sine square beta plus sine square gamma is taken as k. So when you add them, it is very usual aspect of cos square alpha plus sine square. It is what? 1. Again this also what? 1 plus this also 1 is equal to 1 plus k. So definitely 1 get cancelled, you got to take is equal to this. So you know your requirement is k, then automatically you got answer as a k, that's equal to 2. So what? 2 is the sine square alpha plus sine square beta plus sine square gamma. So cos square alpha plus cos square beta plus cos square gamma is 1. Sine square alpha plus sine square beta plus sine square gamma is equal to 2. So there's one more interesting result in that pattern. Look here, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now you got that sine square alpha plus sine square beta plus sine square gamma is also 2. So when you subtract it, you know, it is a cos square alpha minus a sine square alpha. And here it is equal to subtracting you got that cos square beta minus sine square beta. And this is a cos square alpha gamma minus a sine square gamma is equal to 1 minus 2. You know, this is a cos 2 alpha. And here it is a cos 2 beta. And finally it is cos 2 gamma is equal to 1 minus 2 is minus 1. So this 3, keep in mind 1. If alpha, beta, gamma are direction angles of a vector, that means a line which define with the x-axis, y-axis and z-axis are angle alpha, beta, gamma, then they are known as what? Direction angles. and if you correspondingly choose the value cos alpha, cos beta, cos gamma, they are referred as a direction cosines. Then every such a expression, cos square alpha plus cos square beta plus cos square gamma equal 1. So if alpha and beta are given, then you are able to find gamma. Likewise, if it is sin square alpha plus sin square beta plus sin square gamma, just to add together will give you k, or the value is 2. But using that too, when you subtracting both, it will provide a new one more equation, that is cos 2 alpha plus cos 2 beta plus cos 2 gamma is always minus 1. So keep in mind, so some useful expression is there. Okay. Now question number 12. The vector cos alpha cos beta I plus sin alpha sin beta j plus sin alpha k is, is a null vector, unit vector, constant vector, none of this. First option is null vector. What's the definition of null vector? A vector whose magnitude is 0 is referred as a null vector. What's unit vector? Unit vector is a vector whose magnitude is 1. So it is a unit. So the magnitude is 1. And a constant vector means what? It's actually a vector having no change, always be same. So everywhere they want to find what's the magnitude of the given vector. So you start to write down this as in the form. Our R bar is equal to cos alpha cos beta into I plus cos alpha sin beta into j plus sin alpha into k. This is the given vector. So the first option being null vector, second being unit vector, third is our constant vector. You just find what's the magnitude of the vector. So I put them mod R bar. So mod R bar is equal to square of this is cos square alpha cos square beta plus cos square alpha sin square beta plus sin square alpha is that. So we can choose cos square alpha be common, is equal to cos square alpha into cos square beta plus sin square beta plus sin square alpha. So what is cos square alpha plus sin square beta? It is 1. So you can replace the trigonometrical result as 1. So cos square alpha into 1 plus sin square alpha. So beautifully again you can add the same result as to become 1. Means our mod R bar is equal to mod R bar square. So mod R bar square is equal to 1, or mod R bar is equal to 1. Mod R bar is equal to 1 means it is not a unit, it is not a null vector, but it is exactly unit vector. So the correct answer is 2. Option 2, which is given there, it is a unit vector. Now you come to question number 13. What is the angle which the vector I plus j plus root 2k make with the z axis? So a line z axis, suppose any vector on z axis be referred as some a bar k, not a bar, a k. A be the magnitude and k is there. So this is a vector along that z axis. So you just find the angle between this AK and that. How to find it? So cos theta is equal to I plus 2j plus root 2k dot AK divided by modulus of this vector, that is root of 1 plus 4 plus 2, and modulus of that is equal to root of some a square. So you have the form, just to expand, it is equal to all of them. I, there is no item, so that's 0 again 0 plus a root 2 divided by, here it is equal to 7 root 7 into a. So a get cancelled, good, it is equal to root 2 divided by root 7. So here also I made a small mistake to select the question from here, this I marked it as what? J. So this is a small change to find the value of this will be 1. So I cancel this. This is equal to root 2a divided by, this is actually 2 and here it is only a, get cancelled, it is 1 by root 2. So cos theta is equal to 1 by root 2, then theta is equal to pi by 4. The option given there, pi by 4 on the first one. Option 1 will be correct answer. Now, if a bar and b bar are vectors such that mod a bar is root 2, mod b bar is equal to 2, and A dot B equal root 6. Then angle between A bar and B bar. It's a very simple problem. You know, A bar dot B bar is equal to AB cos theta, where A and B are magnitude given there. So A dot B, that is root 6, is equal to root 3 into 2 into cos theta. You want to find what about the angle between them. So this is theta here. That's equal to cos theta is equal to root 6 divided by 2 root 3. So initially it is equal to 1 by root 2 is there. X angle theta is equal to what? Pi by 4. So simplifying, again you got the answer as what? Pi by 4 option 3 is there. So just to replacing what is the definition of A dot B. If it is A dot B is what? Is equal to AB cos theta. Then the given value A and B and A dot B are replaced and you can easily find what about the relation for cos theta. So here it is equal to 1 by root 2. Then correspondingly theta is what? Pi by 4. Now question number 15. If A bar is equal to 2i plus 4j minus k and B bar is equal to 3i minus 2j plus 4k be such that A bar perpendicular B bar, then what is lambda? This is our question. You know, A bar and B bar is given and such that A dot A perpendicular B bar. You know, when A bar is perpendicular B bar, this provide you A bar dot B bar equal to 0. If two vectors are perpendicular, then dot product is equal to 0. So here it is equal to 2i plus 4j minus k. 3i plus 2j plus lambda k, just replacing lambda is there. The problem is containing only 4. I mark that 4. Sometimes it may not correct answer. So look here, 2 times 3 is 6 minus 8 minus lambda is equal to 0. Therefore, you got a minus 2 minus lambda is equal to 0 implies that lambda is equal to minus 2. This is the answer of the question. So the question you have a small change that should be lambda. Here it is marked only as 4. So please correct it with lambda. Now question number 16. The distance of the point 3, 4, 5 from Z axis. You know, in XY Z plane, there's a point. Is this in space? Then definitely I mark here. Then definitely this foot of the problem here. If it is X axis, Y axis and Z axis, then definitely P, A, B, C. Then this foot is actually what? A and B and 0. You know, Z is corresponding here and A is corresponding to this and B is there. So you want to find the distance between that two. You know, what's the corresponding distance of the point 3 from Z axis. So this length is required. What is the distance? So definitely the distance is actually this one. So we can find this 2 as what? Yes, here it is equal to A and this length is B. So this distance of the line is root of A square plus B square. So when you take the simple situation is there, if the point is B, X, Y, Z, X, Y, Z is there, then any point correspondingly the projection on that Z axis is P dash is equal to 0, 0, Z. When you choose the Z axis is there, take the projection towards there. Definitely whose X values and Y values are 0, then the foot is lies on the X axis. This is actually I mark them P dash, this is for P. So this foot is exactly 0, 0, comma, that here it is C. So as per this expression, what about P dash? P dash is the distance, that is the square root of x minus 0 the whole square plus y minus 0 the whole square plus z minus z the whole square is there. So it is equal to x square plus y square plus 0. So root of x square plus y square is the answer corresponding to the distance. So if P, X, Y, Z is a given point to you and you want to find the distance of that point from Z axis, then sum of the squares of other two coordinate x square plus y square and take the root will give you the distance. If you want to find a point, the distance of the point from y axis, then root of x square plus z square. If you want to find the x axis, root of y square plus z square is the direct way. So here, root of 3 square plus 4 square, you can see that the point being 3, 4, 5. So 3, 4, 5 be the point as given. Then corresponding P dash which is a foot on the Z axis. Therefore 0, 0 and 5 is there. Then no problem. Just to make the difference, you know, p dash is the root of 3 square plus 4 square is exactly 9 plus 16, 25 root 5. So 5 unit is the distance of the point that from Z axis. So this is the simple technique to find the distance of the corresponding given point. Sometimes it is given to the plane there like this. So here it is equal to the axis. So you can make the sum of the squares of other two coordinates will provide you the distance of the corresponding point from the corresponding axis. Now question number 17. Planes Bx minus Ay plus 0 Z is equal to N, one line, one plane. And second one, 0x plus cy minus bz is equal to L, question number 2. And minus cx plus 0y plus az is equal to m. So question number 3. These are three planes. You want to find the condition for this line, this all planes intersect on a line. So what's the feasibility of the problem? You know, when there is a such question, you can identify one plane. This is one plane. And I mark another plane as here. So definitely there is a line through this both of them. Now, one more plane is there, which is containing this two line. I mark here. So definitely the three line passes through a common line this. So that's very interesting. You know how to find the plane this. I mark this one is equal to P3 and this one is equal to P1 and here it is equal to P2. So this is a very simple techniques there. You know, when two planes are intersecting, you can find the combined equations of the plane, any plane which passes through P1 and P2. So equation of a plane passes through P1 and P2 is equal to P1 plus a constant lambda P2 is equal to 0. This is the combined equation of plane. So here 1, 2 is there. You just provide the combined equation of 1 and 2. So equation 1 and 2 will be there. 1 and 2 provide the situation as bx minus ay plus 0 z minus n, the first one, this. Plus lambda into the second equation, 0x plus cy minus bz minus l is equal to 0. It's the combined equation of 1 and 2. So we can club together to write down the good form as only some bx is there and y I mark them as plus y into lambda c minus a minus b lambda z. There is no z term here. And finally it is equal to minus n minus l lambda is equal to 0. This is our combined plane. You equate the plane along with the third one because the third plane is also passes through the same line. So we can keep that plane, the equation of this plane is exactly 3. Or this will be marked as 4 and you club this one with our equation number 3. That means minus cx plus 0y plus a z minus m is equal to that. This is the equation. So now this will be same, only what? Only this b equal to minus c. And at the same time, c lambda minus a equal to 0. And minus n minus l lambda is equal to minus m. These are the three conditions. There is one more condition is there, minus b lambda plus c. There's no one need of that because it is minus e. So we can find here as in the form b is minus c or c is equal to minus b is there. And here lambda is equal to a by c. So we can come back to this equation. This equation n plus lambda l is equal to m. I cancel that minus m and remove this lambda. I got that n plus l a by c is equal to m and c n plus a l is equal to c m. So now you please go through the options that are given there. AL minus BM plus CN is equal to 1. AL plus BM plus CN equals 0, etc. Look here. Here, M along with all the given condition L and M are there. But you know, along with the M, there is not constant with the C. Is given B is C is equal to minus B. So we can replace that C as a minus BM. That idea is actually I go through the questions option along with the questions of M. You can observe them that M is multiplied with a constant B, and here you obtained as what C. So you know that from the equation B is equal to minus C or C equal to minus B. So we are able to replace that C with the minus B. Then you can choose them to left side. Therefore, AL first plus BM second plus CN is equal to 0 be the answer corresponding there. And here there is an option 2 is there. So this is a simple observation happen with them. You have three equations of plane. So you club together as per the condition as P1 plus lambda P2 and equating that plane with our third equation, you can observing the coefficients relation. And from the coefficient relation, you can observing which will be suitably along with our conditions or given options. This is a simple technique to find the option. Now, question number 18. Here L is equal, M is equal, N represent the direction ratios of x-axis, y-axis and z-axis. So, you know, what's the direction ratio of x-axis? Direction ratio of x-axis is actually 1, 0, 0. Only x-coordinate is there. And both the Z and Y, there is no such component, then you can keep them. You know, one of the equation like this, x minus x1 divided by A is equal to y minus y1 divided by B is equal to Z minus Z1 by C. Suppose it is only represent an x-axis, both of them will be here, should be 0. Then only that should be x-axis. If xy plane, then that should be 0. This is a situation, you know, there is no such is parallel on the xy plane, then definitely A and B is there, but there is no such Z minus Z1. So we can easily observe them that dash ratios of x-axis is A 0, 0. So simply we can choose it as 1, 0, 0. And that of y-axis is 0, 1, 0. And z-axis is 0, 0, 1. But given it is 1, 1, 1 with the direction ratio, that means they are equally inclined. Equally inclined line definitely on the space, not any axis. So none of these be the correct answer for the option. So we can easily observe the question and easily identify that by reading carefully through the notes in our vector and 3D. Okay. Now you can come back to the next problem, question number 19. The line passing through the point 51A and 3B1 crosses the YZ plane at a point 0, 17 by 2 minus 13 by 2. Then what's the values of A and B? You know, there are 2 points. I mark them. P is equal to P is 5, 1 and A. And there is another point Q. Q is 3, B and 1. Suppose one point is here and is there. Now there's a plane crosses that. You know, this is the line, but the plane crosses it somewhere. I don't know exactly. I marked as R. This is our YZ plane. So the point in YZ plane definitely whose x coordinate is 0. So x coordinate of R should be 0. And at the same time, here it is P and that should be Q. Then there is a L and M. These are the ratio. So we can write down the equation for R. R is equal to LQ plus MP divided by L plus M. Therefore, you know, R is given as what? 0, 17 by 2 and 13 by 2 with a minus sign. 0, 17 by 2 and minus 13 by 2. But you don't know what is L. So L times of Q. Q is a second point which is given as 3B1. 3B1. And M is the first point, that is a 5, 1A. 5, 1A. So divided by L plus M. So this is the equation. So your aim not find L and M, but to find what is A and B. So the process inside the problem, you know, there's a point 0. This 0. This 0 we can connecting with the L and at the same time we can connecting with the M. That means 0 is equal to 3L plus 5M. You can expand that whenever you multiply with this and divide by L plus M. But if you get 0, this cross multiplication 0 is equal to 3L plus a 5M. Then you can easily find 3L is equal to minus 5M, or L by M is equal to minus 5 by 3. So, or 3 by 5. Anyway, we can put that. So, you can keep the form as 0, 17 by 2 minus 13 by 2 is equal to L is minus 5. That is equal to minus 5 times Q. What is Q? Again 3B1 plus 3 into the next 51A. 51A divided by minus 5 plus 3. So, you can equating this to, minus sign we can cancel 5 times 3, 5, 1. Not 5, it is B. And minus 3 into 5, 1, A divided by 2 is there, and left side is 0, 50, 17 by 2 and minus 13 by 2. So equating this to equation. Look here, 5 into 3, 15. 15 minus 15 becomes 0, you got already. This is the condition for that L and M. Now you can connect it with 17 by 2. 17 by 2 our y coordinate form. This will be 5B minus 3 divided by 2. So this implies that 17 is equal to 5B minus 3, or 20 is equal to 5B, or B is equal to 4. So you can find B is equal to 4. At the same time, minus 13 by 2. Minus 13 by 2 is equal to 5 into 1. 5 minus 3 into A divided by 2. So again we can cancel 2 first. And you got that 3A to left side and 13 to right side become 5 plus 13 is 18. Therefore, A is equal to 18 by 3 is equal to 6. So, A equal to 6 and B is equal to 4 be the correct answer for this problem, and which is given in your option 4. Now, question number 20. The distance between the line R bar is equal to 2I minus 3J plus 3K plus lambda into I minus j plus 4k and a plane R bar dot I plus 5j plus k. It is very difficult question. Easily, difficulty is there. If there is a plane and there is a line. Suppose this is a plane and there is a line. If it is some way in this form, definitely you are not able to find a distance because it is varying distance. Still they want to find a distance means definitely this line is parallel to the given plane. Then only you can find a distance. That means if the plane is there and that should be parallel means if you draw the normal and that normal is definitely perpendicular to the line, then only it is parallel. The normal of the plane n bar is equal to I plus 5j plus k, and b bar is the line direction ratios of the line. So that should be a question of lambda. There is a I minus j plus 4k. Now we can observe them. What about that n bar dot b bar? N bar dot b bar is equal to 1 minus 5 plus 4 is equal to 0. Clear. So the given line is what? It is parallel to the plane. The given line is parallel to the plane and you want to find a distance. You choose any one of the point inside there. Look here. Here there is a plane and this is actually parallel to here and so many points are there. I choose any one of point and the distance should be here. This is actually the distance. So you want to find the distance of the line which is parallel to a given plane. You just find the distance of the point on the line to this plane. So distance from a point to a plane. X1, Y1, Z1, B, any point in the which is not on the plane, and the equation of the plane is ax plus by plus cz plus d equals 0. Then perpendicular distance from P. Perpendicular distance from P is equal to, you just replacing ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. So, in our coordinate geometry, two-dimensional geometry, distance of a point x1, y1 to a line ax plus by plus c equals 0 is ax1 plus by 1 plus c divided by root of s plus b square. Now for 3D, that should be exactly extended. That means the point become x1, y1, z1. And the equation of plane, that is extension of equation of line in 2D, which is what? Ax plus by plus ez plus d equals 0. So what may be the conditions in 2D that can be extended in the plane or the 3D form? That means distance, peripheral distance from x1, y1, z1 to that plane is simply replacing the coordinate x1, y1, z1 to this plane divided by root of a square plus b square plus c square will provide you exactly the perpendicular distance. So here you want to find perpendicular distance of the given line to this plane. You need to choose a point from the line. But you know, one point is 2 minus 2, 3, which is given initially. The line should be r bar is equal to 2i minus 2j plus 3k plus lambda into I minus j plus 4k. And the plane is, the equation of plane. Equation of the plane is r bar dot I plus 5j plus k is equal to 5. So, you know, this line and this normal, you can check them whether they are parallel or perpendicular. So we can here it is that should be parallel. Now we can find any point here. The point is P be referred as any point 2 minus 2 3. This is the point of any point inside there, and the equation of the plane can be extended as taking product with the x1 bar. You got at x plus 5y plus z minus 5 equals 0. So this is in the good form. You are able to applying it directly. So the required distance d is equal to 2 minus 10 plus 3 minus 5 divided by root of 1 plus 25 plus 1 and modulus of it. So it is equal to 10 divided by root 27. So it is 10 divided by root 27 is equal to 10 by 3 root 3 is the required distance, and which is given in your fourth option. We come to this problem. That's actually the angle between any two diagonals of a cube. So, you know the cube. So, any two diagonals. So, we can identify, suppose if it is unit length or whatever, maybe whether it is a unit here and here a and here a, then we can identify each and every point. You know, this is O. O being referred as 0, 0, 0. Then I mark this x-axis and here it is equal to A. For A, we referred as A, 0, 0. And now I choose this one is equal to y-axis, that is B. So B is 0, A 0, and here it is equal to z-axis. So I mark them as C is equal to 0, 0, C. Now I choose the opposite sides. That means the point A is x-axis, then this coordinate be referred as A dash. That A dash be a point on y-z plane whose x coordinate is 0, and other two answer their corresponding coordinate. So that should be A dash, then 0, A is the coordinate. Look here, if it is y-z plane, the x coordinate is 0. So again I mark this B dash. B dash is actually the opposite vertex here. That's actually B dash. Then you can see that is equal to A 0 A. This, if it is a dash, should be there. And corresponding to C dash is opposite coordinate. That is actually A 0. So here it is equal to, if it is C, then I mark this one as C dash. Now there is one more point O, and O dash is there. So this better O dash is here as a A. That's actually point on the space. So with the dash and this norms, we can identify different sign like that is O dash. This is O to O dash. This is a diagonal. Likewise, A dash is another diagonal. You can identify one more diagonal, and this all this diagonal. This is also a diagonal. like this. So there are 4 diagonals. You want to find the angle between any 2 diagonals. So you just take this one diagonal is OA. You want to find O dash. It's a diagonal whose direction ratio is equal to A minus, that is A is the one diagonal ratio. Similarly, A dash is again there. It is equal to, just to separate here to there, that's minus A is there. And if it is B dash, sorry, B A dash, B dash. Choose that two, you got at A0, A minus A, and the last single C dash. Other directions of any that is equal to here, this is equal to A there. So A minus A. So look here, the interesting situation is that you identifying the diagonal, all that direction ratios are A each. And after that, one should be shifted as minus A. You can take any one of any 2 of this, and after we can find the angle between them. So angle between these 2, angle between O dash and A dash. You can choose any other, no problem. So it is equal to cos theta. Cos theta is equal to this minus A square plus A square plus A square. That's a dot product between these 2. I shall write down initially the form O dash dot A dash. It will be mod O dash, and this to be vector. So A dash is also a vector. This modulus is there. So we can observe that 2 are in the form. Then we can find a very good condition there. Is equal to this 2. Dot product of that 2 is a minus A square plus A square plus A square divided by root of A square plus A square plus A square into root of A square plus A square plus A square. So initially you can cancel one A square from numerator, this 2, and A square divided by this is root of 3A into again root of 3A. That's equal to A square divided by 3A square, then get cancelled at 1 by 2. Therefore cos theta. Without that A value, then theta is equal to cos inverse 1 by 2. So if theta is the angle, then cos theta is equal to 1 by 3. So here it is given as option 3. So you can choose it any 2 diagonals. If it is A dash and B dash, then also we can find it. Better we can identify this naming scheme as A for x axis, then B dash for y z plane. Again, B on y axis is a point on y axis, then B dash is a point on I axis plane, likewise. Then we can easily mark that. If it is 0, 1, 0, 0, then we can put the values as exactly with 1, 1, 1. No problem whether it is A or any other constant. Then because of cube, the diagram, the values distance be exactly same. So it's a nice problem. You can solve them that cos it is 1 by 3. Now question number 22. The foot of the perpendicular from the origin to a join of A minus 3, 4, 5 and B 11, 0 when some divides AB in the ratio what? It's a very nice problem. You know, there's an origin. P referred as 0, 0, 0. If you draw a foot of the perpendicular on the line joining this A and B, I mark here it is A and that should be B. And A is given as minus 9, 4, 5. And B is given as 11, 0, minus 1. And this one is referred as C. You want to find what about this L and what about this M. Because that C divide the line joining AB in the ratio list here. You want to find the ratio L and M. But it is not given that, this is only given that this is 90 degree. That means here, if the point B origin O, then you can see that OC, the vector OC is perpendicular to vector A. This is the situation. So, you know, if you know the direction ratios of A and B and that of OC, then the product and sum of the direction ratio should be 0. This is a situation you can solve for what's that. Look here, I come back to the formula. this. I initially find what about at C. The coordinate of C is L times B plus M times A divided by L plus. This is the section formula there. So you can identify the equation as L into 11 0 minus 1 plus M into minus 9 4 5 divided by L plus M is there. Now, you can find the coordinate as L 11L minus 9M divided by L plus M and 0L plus 4M divided by L plus M and minus L plus 5M divided by L plus M. So this will be referred as the coordinate of the point C, and that of 0 is 0 0 0. So what is direction ratios of vector OC? Direction ratio is a ratio of OCB, difference of that, and all of them have L plus M in the denominator because 0 is subtracted, there is no change on the given value. So whenever you can put the direction ratio, no need of marking L plus M with the denominator. You can directly put the direction ratios are this one, this proportion to 11L minus 9M, then 4M, and finally 5M minus M. Be the direction ratio. It's not a point, but the direction ratios of that was. No need of marking the denominator because it is the same. You want to find the ratio, so we are able to multiply both with the L plus 1, that will be good. Now then you can easily find the equation for direction ratios are 11L minus 9M, 4M and 5M. And what is the direction ratio of AB? Now we come back to direction ratio of AB. Direction ratio of AB is actually there are two different points which is given to you there. One is B and other is A. So we can make the difference of that. 11 0 minus 1, 11 0 minus 9 minus 9 4 5. These are the difference of the point. Then you got that is 20 and 0 minus 1, that's 4 minus 4 and minus 1 minus that's 6. So we can dividing that with 2, it will become 10 minus 2 and minus 3. So these are the direction ratios of AB. Now take the product of these two. That should be 0 and solve for L by M. Look here, therefore, since AB perpendicular OC, can mark them 10 into 11L minus 9M minus 2 into this 2 into 4M minus 3 into 5M minus L is equal to 0. Therefore, 110L minus 90M minus 8M minus 15M plus 3L is 0. So 3 and that's 113L minus 113M is equal to 0. So it's equal to L is equal to M, or L by M is equal to 1, or L is to M is equal to 1 is to M. 1 is the required ratio. So option is 3. So we can find the answer in this pattern. You can easily find the dot product between that OC and AB. You can initially find the coordinate of C by choosing L and M. So instead of L and M, if you are able to represent the lambda unknown is also a technique to find the ratio. Sometimes whenever you want to find the lambda, that may be a ratio. Here it is exactly, if you represent with the lambda as 1, then you can see that the lambda is exactly 1. Okay. So anyway, we can find the problem. Now, question number 23. In 23, it is given to you that it's not actually gamma, it's actually R bar. We can keep it as what? R bar, or R bar B is referred as a variable point in vector R bar is equal to B A bar. And this is equation number 1. And R bar cross B bar is equal to A bar cross B bar, equation number 2. The point of intersection of lines you want to find. So you want to solve it. How to solve this? You look the equation. You look the right side is B cross C and left side is A cross B. So, what is the difference between A cross B and B cross C? You know that B bar cross A bar is equal to minus A bar cross B bar. So here you can identify first equation is R bar cross A bar is equal to B bar cross A bar, which will be represented by minus A bar cross B bar, so that we can put minus of R bar cross B bar using our second equation. So here you got two expressions as R bar cross A bar is equal to minus R bar cross B bar. So we can choose to left side R bar cross of A bar plus R bar cross B bar is equal to 0. So we can choose that R bar cross of A bar plus B bar is equal to 0. This is the condition for that way. This means when you know this R cross B, A plus B is then definitely that R bar is also a multiple of A cross B, which should be parallel to A plus B. So this is the way you can identify the point of intersection, which is solving that too. So definitely that result R bar is A bar plus B bar, which is given in the option only A bar plus B bar is there. You know, this guarantee A cross B is equal to 0, then A is parallel to B. That means R bar cross of A plus B equals 0 means R bar is parallel to A bar plus B bar. So any vector parallel to A bar plus B bar may become the value for R bar. But here you want to find an exact point which is given in the option transport only with the R bar plus A bar. That should be a multiple of A plus B. So we can conclude that the required situation is A bar plus B bar. Suppose if it is a 3 times A bar plus B bar also, then we can choose them also the correct answer. So here now problem is A bar plus B bar is the correct answer for the problem. Now come to question number 24. Under what condition does the straight line x minus x naught by L equal to y minus y naught by M is equal to z minus z naught by N is parallel to xy plane? So line parallel to xy plane means there should be a constant for z value. You know, in the situation of a line, right of this x minus x naught by A is equal to y minus y naught by B is equal to z minus z naught by C. You know, if the points on the A is equal, suppose 2 points are there, x1, y1, z1 and x2, y2, z2 are 2 different points on there. Then what about the action ratios of the line? During them, it is exactly x1 minus x2, y1 minus y2 and z1 minus z2 is there. Instead of that 2 points, they are on the same plane or the yz plane. That means what? It is actually xy plane, so the z coordinate is constant. So z coordinate is constant means this value is z1, here also is z1. So z1 minus z1 becomes 0. So the rational ratios are, if it is A and this is B and that should be 0, then you can write down A, B and that is C as that 0. So when you want to dividing with the equation of a line like this, you know, x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z2 by z2 minus z1. If it is only on xy plane, whose z coordinate will be always same. That means these two are equal. So this becomes 0. In such situation, we are able to write down the equation like this: x minus x1 divided by some constant A equal to y minus y1 by some constant B, and z minus z1 divided by some another constant 0. If it is marked by 0, this is only a mathematical situation to accept the division with the 0. When you dividing with the 0, z minus z1 by 0 is how we can accept this right up. This means here z be exactly a constant of z1, always be constant. So we can sometimes we are able to write down the same situation as x minus x1 divided by A is equal to y minus 1 by B and semicolon by putting z is equal to z1. Z equal to z1 means the coordinate of z is always z1. That means it is varying only in xy plane. So this is the situation for writing a line in xy plane, and this exactly it is in the plane containing xy, and there is no such value correspond to that of z. That should be always constant. Now you read the question here. Here x minus x1 by L equal to y minus y naught by M is equal to z minus z1 is a parallel to xy plane. That means always that z be a constant. That means there is no value in the denominator of the last term. There is a z minus z0 by 0 if it is required. That means n should be 0 is the correct answer correspond to the problem. So option 3 is that. Now question 25. The area of a triangle whose vertices are 0, 0, 0, 3, 4, 7 and 5, 2, 6. You know, in the case of a triangle, if it is equal to A bar is one side and B bar is another side and C bar is also there, then you know that if they are in the cyclic form ABC, definitely that A bar plus B bar plus C bar is equal to 0. And this is if it is in that opposite direction, then we can set A bar plus B bar equal to 0, no problem for that. Then if it is in that form, how to find the area? You know that area is equal to, you choose any two sides, let's say A bar cross B bar and its modulus, and half of this is equal to 1 by 2 in the model B cross C, or 1 by 2 in mod C cross A will provide a magnitude which is exactly the area. You know, in the parallelogram, if it is a parallelogram like this, and this is A bar, here also A bar. If it is B bar, it's also B bar. Then this line is the height. Then area of the parallelogram is what? A into X. So if you convert this one, if you know this angle, this is a triangle, then definitely you are able to convert it as what? It is actually height. Then that should be A cross B. A cross B is the area of A cross B is the area of a triangle. Then half A cross B is the area of the parallelogram. Then half will provide the area of a triangle here. So here, 3 different points which is given to you there. So one point is 0, 0, 0, and other point A is 3, 4, 7, and the last point B is equal to 5, 2, 6. So I mark like this. This is equal to 0, and here it is equal to A, and that should be B. So you know this side OA and that side is OB. So what's the area of triangle here? Using the situation, delta is equal to 1 by 2 into mod vector OA cross vector OB. These are two sides of triangle. You know, vector OA and vector OA with respect to 0, then directly it is what? It is equal to 1 by 2 into 3 plus 3i plus 4j plus 7k cross 5i plus 2j plus 6k. So you just find a cross product of that vector and take the modulus will provide exactly what is the area. So it is 1 by 2 into determinant I, j, k, and 3, 4, 7, and 5, 2, 6 be the vector area of this triangle. So you can find unity with the vector, and after you can find the modulus. So the vector is actually I into 24 minus 14 minus j into 18 minus 35 plus k into 6 minus 20. So this will be 1 by 2 into 10i, and this is equal to 17. So 17j and k, that's actually minus 14k. So this is vector area of the triangle. Now you are able to find the areas in the form 1 by 2 in the square root of 100 plus 289 square of 17 plus 196. So we can conclude this one as 289, 196 and 100. So 5 is the 8 is the 588. 85. So it is actually we are able to dividing that with 9. So it is equal to 6 times the, so 54 again 45, that's actually 9, 65. So this will be written as in the form 1 by 2 in the square root of 585. So that's equal to 1 by 2 into some square is 9 into 65. That is 3 by 2 root of 65 is the answer. It is given in our first option. So we can easily find the answer by using cross product. Cross product of two vector any two sides is the geometrical meaning is the area of half the area of so area of a triangle. So it's 1 by 2 into A cross B. If A bar and B bar is there, A cross B is the area of the parallelogram formed by the adjacent sides A bar and B bar. So the triangle will become half of the A cross B. Now, question number 26. 4 points is there. It's actually, I mark them as what? Vector A. Vector A is equal to 4i plus 5j plus k. And vector OB is equal to 0i minus j minus k, and OC is equal to 3i plus 9j plus 4k, and the last OD is equal to minus 4i plus 4j plus 4k. These are 4 different words. They are on the right. Look here. Suppose I mark them initially. A here and B is there and C is there and D is there. We don't know whether it is on the same plane, but the common point with the origin is there. Here it is. So you know this is actually a position vector, and this is also a position vector, and here also a position vector, and here also a position vector. I mark this one as A, B, C, and D, which is given. But how to find they are on the same plane? That's a nice idea. You keep any one of it. I mark this A, and I find this vector AB and vector AC and this one. So we are able to find 3 such vectors. They are A bar is equal to vector AB, and small b bar is equal to vector AC, and C bar is equal to vector A. These are I mark 3 different vectors. Here it is A bar, here it is B bar, and here it is C bar. So if 3 vectors A, B, C are coplanar, definitely the box product A dot of B cross C is 0. So for coplanarity, you know the condition for 3 vectors A bar, B bar, C bar are coplanar, then box A, B, C is equal to 0. Why I initially go to coplanarity? Because in the option there are collinear, coplanar or non-coplanar. Unlike so, coplanar and non-coplanar is a basic aspect of 3 different points. If it is coplanar, then we can think about them whether it is collinear or not. So coplanarity is one of the big conditions because sometimes it is coplanar or not. So come to this identifying what is A, B, and C as per the given condition. Look this, how to find this? It is very simple. Now we are able to find what about that A bar. Small A bar is equal to difference of OA to here OB. So I make that OB 4 and some, so this will minus 4i and minus 6j, and finally minus k, that's minus 2. This is actually A bar. Now B bar. B bar is what? B bar is AC. That's anything of that. That's minus I plus 4j and 4k minus that is plus 3k. That's actually B bar. And finally C bar is equal to this minus that. Minus 4a minus 4 is minus 8i, and 4j plus that's equal minus j, and finally 4k minus k is 3k. This is our ABC. Now you find what is box ABC. Box ABC is the determinant using the coefficient directly minus 4, minus 6, minus 2, and minus 1, 4, 3, and minus 8, minus 1, 3. Now you expand the value for determinant as in any way you know. So I put that what minus 4 into this 12 plus 3 plus 6 into minus 3 plus 24 minus 2 into 1 plus 32. So this is minus 4 into 15 plus 6 into 21 minus 2 into 33. So I proceed to find answer as a minus 4. This one is minus 60 plus this is actually 126, and here it is minus 66. So adding this 2, it will become minus 126 plus 126 is 0. So box product of ABC, there is a vector AB, AC, AD are coplanar. So definitely the point A, B, C, D are coplanar. So this is the way how we can observe the given 4 points are coplanar. If given 4 points are there, you just find keeping any one of them, let's say is the and find AB, AC, AD. They will provide exactly 3 different vectors, and condition for coplanarity of box product 0 can be applied easily. Now question number 27. The direction ratios of the normal to the plane passing through the point 1 minus 2, minus 1, 2, minus 1 and parallel to the line x minus 2 by 2, y minus 1 by 3 is equal to z minus 4 is. The equation direction ratios of normal to the plane. Direction ratios of normal to the plane is, you know, a line is here and a plane is there. Suppose if this line is parallel to this plane, definitely the normal make a 90 degree with the line. Suppose ABC with the rational ratio of the line, then this B bar is perpendicular to that on ABC. This is the first condition for it. And at the same time, you can easily write down the equation as equation of any plane passing through that point. That's why I mark that A into x minus 1 plus B into y plus 2 plus C into Z minus 3 is any plane passes through one of the point of this with the rational ratio ABC. You want to know what is ABC. So this plane is again contain this line, this point means we can replace that x with minus 1. That is A into minus 1 minus 1 plus B into 2 plus 2 plus C into minus 1 minus 3 is equal to 0. That means minus 2A plus 4B minus 4C equals 0. Now we are able to dividing with the minus 2. We are written as A minus 2B plus 2C equals 0. Keep the equation for 1. So first 2 points you can identify a relation connecting direction ratios of this series. Now you know that these direction ratios are perpendicular to the direction of this line. You look the line as x minus 2 by 2. If it is reversed, we can replace that minus 8. No problem here. X minus 2 by 2, y plus 1 by 3, and z minus 0 by 4. So 2, 3, 4 with the direction ratio of a given line. That direction ratio is perpendicular to ABC means we can conclude the next one as what? 2A, again 2A plus 3B plus 4C is equal to 0 is equal to 0. Because the line is perpendicular. So we have two equations. Now you are able to solve the equations. Anyway, we can solve the equation that I just multiply the first one. Answer by 2 here. That's equal to 2A minus 4B plus 4C is equal to 0. Subtract then AB cancels. So 7B is equal to 0 implies that B is equal to 0 is one of the important part. When B becomes 0, A equal to minus 2C. So you can keep that C is equal to some lambda, then A is equal to minus 2 lambda. And B is equal to what? 0 lambda. So what about the direction ratio? Direction ratios are exactly minus 2, 0, 1. This is the. So when you multiply by minus 2, 0 minus 1 is also the direction ratio of the required range. So when you multiply with minus n, you get 2, 0, minus 1 is also the direction ratio of the plane. So now problem whether it is multiplying all the time with minus n will provide the same direction ratio of the plane. Okay. So here the option 4 is the corresponding answer. Okay. Now question number 28. The length of the perpendicular drawn from origin to a line 4i plus 2j plus 4k plus lambda times 3i plus 4j minus 5k. So this is a line. So I mark 3i plus 4j minus 5k is there. It is actually here. This is the line parallel to this vector. And I mark one of the point on the line is exactly 4i plus 2j plus 4. This is one of the point. And there's a point origin is here. Origin is there. Because you want to find out distance from origin. And you want to find this distance. What about this distance? This is our distance. So I mark this point is equal origin and this point is A. So if you draw this vector, I mark them AO and keep this will be here exactly that. So how to find this edge? It's a very simple thing. When you complete a triangle, with this side is exactly that A and here this will be. Suppose AB is this 4A plus 3A plus 4J minus 5K. AB is here. And A is this vector, that's O2 here. We can identify the vector by choosing this one from O. This will be 4i plus 2j plus 4k. So these are two vectors. Then you know the area of this triangle using this two. How to find the area? There is a magnitude of this OA and AB cross of half of OA cross AB. So area of the triangle is equal to delta is equal to 1 by 2 into modulus of AO cross this is AB. So using the cross product of this two vector, you know A is exactly 4i plus 2j this vector because that is also 0, 0. So you just find the area as finding determinant I, J, K is there. And this 4, 2, 4 is there. And 3, 4, minus 5 is there. So just you find this delta as finding I into minus 10, minus 16, this minus J into minus 20, minus 12, plus K into 16 minus 6. So this is equal to minus 26I plus 32J plus 10K along with the 1 by 2 is there, because there is 1 by 2 for the area of a triangle. This area for triangle 1 by 2 is there. So when you choose the 2 outside, then area, vector area of a triangle is equal to minus 13I plus 16J plus 5. Therefore, area is equal to square root of 169 plus 256 plus 25. So 169 and 256. So 5, 2 plus 25 is equal to 450. This is vector area and its root is there. So root of 450 is there. That's 3 root 5. Is the area of that triangle. Now how to find the height? This is, area is also written like this 1 by 2 into mod AB into H. That's our requirement. This 1 by 2 into modulus of AB is equal to square root of 9 plus 16 plus 25. That's equal to 1 by 2 into root of 50. That's equal to 5 root 2 by 2. Here, this small mistake inside them. This actually not a 3 root 5. This is equal to 3 root 50. And here also 1 by 2 root 50 is there. So area is equal, area of triangle is equal 1 by 2 in the root 50 into x. And already this area is equal to 3 root 50. So we can equating to the and solve for x. That's 3 root 50 is equal to 1 by 2 in the root 50 into x. Or h we cancel, but h is equal to this. So here, you can identify the expression like this. Suppose this is the vector that is 3i plus 3i plus 4j minus 5k. 4j minus 5k. And here this is the vector, the line from origin to that point we can easily observe them 4i plus 2a plus 4k. So two aspect is we complete a triangle like this and you want to find the section. So first of all, you make the cross product of that. So that cross product will guarantee what about the area of this small triangle, and at the same time you can find area using this to condition h and this modulus. So equating and solve for h, it will exactly by 6. So otherwise you can come to the same situation like this. Consider this parallelogram. Again, modulus of this into h, a into h is equal to modulus of a bar plus b. This also, I put this is a bar and this is b bar. Then also we can easily find the equation for whatever that is inside that. So from a point to this line, we can easily find the perpendicular distance from a point to this line. I generalize the situation that, if our r bar is equal to some a1 bar plus lambda b1 bar, and any given point a2 is there. Suppose a2 is here and a point is here as a1 bar and this is parallel to b bar. Then you construct this point as what a2 bar minus a1 bar. And you want to find this height, you complete the parallelogram first. Then the area of the parallelogram is actually mod is equal to a1 bar minus a2 bar cross b bar is the area of this parallelogram. And its modulus will be here. And exactly this is actually mod b into that height. H. This is h. That actually area of parallelogram, side length to height of it. Then you can find h is equal to a1 bar minus a2 bar cross b bar by mod b bar. It's one of the powerful equations This actually, A2 bar with the outer point there and A1 bar be a point on the line. So the difference will taken and take that with the cross product. That cross product divide the magnitude of this one. Is exactly the distance happening from A to this line. So this is a good idea to find the height of any point or the distance of a point from a line to a plane or from a point to a line like this. Okay. Now I come to the next problem, question number 29. So actually, Cartesian equation of a line 6x minus 2 is equal to 3y plus 1 equal to 2z minus 2. We already discussed the way, if it is equal to x1 by a is equal to y1 by b is equal to z minus z1 by c star. Then you can easily write down that xi plus yj plus zk is equal to x1i plus y1j plus z1k plus some lambda into ai plus bj plus ck is a vector form corresponding to this expression, and that should be written. This is actually r bar, and this is any point x1i plus y1j plus z1k plus some lambda into a I plus b j plus k, or this should be in the form a bar plus lambda b bar corresponding to a vector form. So this is referred as vector form, and that is referred as Cartesian form. But the Cartesian form is like that is exactly x, y, and z. Each and every equation be kept as what? 1, and they are usually referred with the positive sign. So here, our equation is a 6x minus 2 is equal to 3y plus 1 is equal to 2 z minus 2. So you can keep initially these are divided by 1. But the coefficient of x, y and z are very different, 2, 3 and 6. So you can keep them with the 1 by simply dividing with the LCM all the expressions. So we can find initially you can find that it is equal to 6 into x minus 1 by 3 divided by 1 is equal to 3 divided by y plus 1 by 3, and this is equal to 2 into z minus 1. This actually now we can dividing throughout with the 6. Dividing by 6 implies that x minus 1 by 3 divided by 6 is the dividing by 6 is the like this. Then you can cancel and you get a 2. So y plus 1 by 3 divided by 2, and here z minus 1 by 3 is there. So this is the equation. Then x minus 1 by 3 by 6 is equal to y plus 1 by 3 by 2 is equal to z minus 1 by 3. Now we can narrate the equation in the pattern as a which will be in the form as r bar is equal to this 1 by 3i minus 1 by 3j plus k, this coordinate, this, and plus some lambda into 6i plus 2j plus 3k. By keeping any different value, we can change this point. That will be the situation for balancing the value for lambda. Then you can shift them. So this also we can write down the exact dimension or the rational ratios of the equation. Now question number 31. If a cross b equals 0 and a dot b equals 0, then what happened to the values inside? A cross b is equal to 0 means ab sine theta should be 0. The 10 bar is 0. So this implies that either a equals 0 or b equals 0 or theta equals 10 bar. That's actually 0. But a dot b is equal to 0 is equal to ab cos theta. This implies that a is equal to 0, b is equal to 0, and theta is equal to pi theta. So look here. Here angle between them is 0. Here it is angle between them is pi by 2. That is not simultaneously equal. So definitely the simultaneously equal condition should be what? This vector. So one should be 0. Either a or b should be 0 or both should be 0 is there. So we can read that either a or b, one of the vectors should be 0. Then only both a cross b and a dot b simultaneously 0. So one of them, either a is 0 or b is also 0, or both of them. But no problem, we can keep the option that exactly either a or b is the correct answer, not and it should be exactly correct with the form. while we face such a problem, most appropriate answer should be given. A and B 0 is also actually 0, but it is only a sub case regarding with the other option. So the correct answer is exactly A equals 0 or B equals 0 is there. Now question number 32. If A bar is I plus 2j plus 3k and B bar is minus I plus 2j plus k and C bar is 3i plus j, then A bar plus T bar is perpendicular to C bar. Then what about that C? Three vectors are given there. A bar is here and B bar is also there and C bar is also there. But given that A bar plus T B bar is perpendicular to C bar. Now definitely if you identify A bar plus T B bar dot of C bar is taken, that should be 0. This is a condition for two perpendicular vectors. If two vectors are perpendicular, then dot product should be 0. So expanding, you get is A bar dot C bar plus T times B bar dot C bar is also 0. So you can find that T is equal to minus A dot C divided by B dot C. So you can easily find what is A dot C. What is A dot C? Is equal to minus of A is given as I plus 2j plus 3k dot. C is equal to 3i plus j divided by minus I plus 2j plus k is our B bar dot 3i plus j is our C bar. Now you want to expand the dot product and take the ratio will provide what is T. So here, what's the dot product? Here we can keep that minus I and I dot 3, that is 3 plus 2 dot, that is 2 plus 0. And the same minus I plus 2 minus 3 plus 2 is that. Is equal to minus 5 divided by minus 1 or exactly 5 either way for T. So when T becomes 5, we can find such a positive vector, so such a perpendicular vector to that one C bar. So option 3 is done. Now question number 33. In 33, D, E, F are midpoints of the sides BC, CA and AB respectively of the triangle ABC, and G is the centroid of the triangle, then GD plus GE plus GF is what? Centroid is actually point of intersection of medians. Median is a line which is starting from one vertex to midpoint of the corresponding opposite side. Suppose there is a triangle like this. I mark them, it is A and here it is B and that is C. So here it is a D, then you can remove this one is our median. If AB is this vector and AD is that, definitely that AD, vector AD is equal to half of vector AB plus AC, this two. So 2 vector AD is that is equal to AB plus AC. Listen, these 3 coordinates are actually starting from A. If you consider BE is the next median, definitely vector 2 times B is the sum of other two sides BC and BA. Look here like this. 2 BE, vector BE is equal to BC plus BA, and similarly 2 CF is the next median, hence vector CA and plus CB is that. This is the way to write down where you have the equation of median. So if median and they are starting from a, let us say, sum of the 2 will exactly twice of the median. This is a beautiful situation to find the length of median and so on. But now, more than this, it is very interesting when you add this 3, that's actually 2 times vector AD plus BE plus CF is equal to vector AB plus AC plus BC plus BA plus CA plus CB. Look the expression. That every AB and BA should be get cancelled, and AC is then CA is then get cancelled, and BC and CB is also there. So all the right side get cancelled. One should be opposite vector along with them. So definitely right side is 0. That means AD plus BE plus CF is equal to 0. That means what? If AB, AD, BE and CF are medians of a triangle, then their sum should be zero. Now, if medians are intersect at a point, then definitely the coordinate we referred as what? They are actually this, there, and so it is A, B, C, they are D, E, F. Then this is centroid. So there are so many properties on centroid. Centroid divides that triangle into three equal regions like this. Look here, this is one of the beautiful equations in centroid. These are three. If it is A, B, C, and this is D, definitely centroid divide the triangle into three equal areas. That means if it is equal x, here also x, here also x. That means area of triangle ABC is 3x. So each and every triangle should be 1/3 of the given triangle. So if you know this area 10, then definitely 30 will be the entire area of a triangle. This one is important property. And at the same time, the centroid divide the median into ratio 2:1. That is, this length is twice of that length. This is twice of that length. So, you know, AD is actually what? So, if it is GD is there. GD is 1/3 of AD. So, what is GD? GD, vector GD is 1/3 of vector AD. This is a very important situation. Because along the direction, if you put down AD, this is 2:1 ratio. 2:1 ratio can be classified into the fractional form as if you choose 3 units, out of 1 unit is actually GD. So it is 1/3 of AD. And at the same time, what is GE? Similarly, GE is also 1/3 of that VE, and GF is also 1/3 of CF. So when you add the 3, that's our term. So what about that? GD plus GE plus GF is equal to 1/3 can be taken out with the AD plus PE plus CF. So that should be 1/3 of 0 is equal to exactly 0. So the sum should be 0, our option. So beautiful geometrical properties can be applied to conclude the vector sum should be 0. Now question 34. If G is 100 of triangle PQR, where GP is equal to 2I plus J plus 3K, and GQ is I minus J plus 2K, then the area of our triangle PQR. So we already discussed. Look here, this is a triangle, and I mark them PQR, and it is given to there, G is there, and a vector GP. This GP is given, and at the same time, GQ is also given. These two are given. So GP and GQ are given, and you want to find the entire area. So you already discussed that PQR, area of PQR is 3 times area of GPR. So you just find the area of GPR and multiply by 3 will give you the required answer. So how to find the area of GPR? Because of the vector form is given, then GPR is equal to GPR, area of GPR is equal to 1/2 determinant I, J, K, and this is 2, 1, 3, and 1 minus 1, 2 is applied. After finding the vector form, just to find the magnitude, will give the area for the required GPQ. After we multiply with the 3, will give the exact area for PQR. So I come back to find the vector, that's actually 1/2 into I into 2 minus 3 minus J into 4 minus 3 plus K into minus 2 minus 1. So this is equal to 1/2 into 5I minus J minus 3. This is our vector area of GPQ. Therefore, area of GPQ is equal to 1/2 in the square root of 25 plus 1 plus 9, that's equal to 35. 1/2 in the root of 35. Therefore, area of PQR is equal to 3 times area of GPQ is equal to 3 by 2 root 35 is the answer of the required answer. So 3 by 2 root 35 option 2 is the given. Now question number 35. Given x bar is equal to a bar plus b bar and y bar is given as a bar minus b bar. Modulus of that a is 2 and that of b is given as 3. Angle random is pi by 3. Then what is x cross y? You can easily say that x bar cross y bar is equal to a bar plus b bar cross a bar minus b bar. So this should be a cross a 0. You know, a bar cross a bar is equal to 0. Similarly, b cross b is also 0. And a cross b is equal to minus b cross a. This we are able to choose here. So a cross a 0 and minus a cross b is there, plus the b cross a is there, and at the same time minus that 0. So totally this should be shifted. So 2 b bar cross a bar is our x cross y. Then you want to find what is the modulus of x cross y is equal to 2 in mod of b cross. This is our requirement. So how to find modulus of b cross a? That's equal to 2 into mod b into mod a into sine angle gradient of theta. So it is equal to 2 into mod b is given as 3 and mod a is 2 and theta is equal to pi by 3. Therefore, this is equal to 3 into 2 into sine pi by 3. Sine pi by 3 is root 3 by 2. So 12 into root 3 by 2 is equal to 6 root 3. So this is the requirement and it is given as option. So what it is given to you, that's very important. You can see that x bar is equal to some a bar plus b bar and at the same time y bar is what? Some a bar minus b bar. No need of finding what about that a and b there. You can love to find what is x cross y directly. You feel that a cross is 0 and b cross b is 0. So we are able to find that a cross b and finally we can identify the equation by using the given magnitude and the angle random. So you got that finally 6 root 3 and the fourth option. Now, similarly, our next problem, question number 36. In 36, a bar is 2, b bar is 3, and 2 a bar minus b bar plus 5 is there, and the plus of them is given. You know, a bar plus b bar, the whole square is equal to a square plus b square plus 2 a bar dot b bar. And at the same time, a bar minus b bar whole square is equal to a bar a square plus b square minus 2 a bar dot b bar. So whenever you make the sum, a bar plus b bar the whole square plus a bar minus b bar the whole square is equal to b get cancelled and you get 2 times a square plus b square. You know, mod a square is exactly a square itself. So this 2 is the condition. Now you feel that our exact problem is one, it is given to you as 2 a bar minus b bar was 5. So 2 a bar minus b bar the whole square plus 2 a bar plus b bar the whole square is equal to 2 times 2 a bar the whole square plus b bar the whole square. This is actually given. You know, here it is 2 a bar, here also 2 a bar. So given this one is 5. So 5 square plus 2 a bar plus b bar the whole square is equal to 2 into 2, 4 square, 16 plus b is 3, so it is 9, you got that equal 15. Therefore, 2 a bar plus b bar the whole square is equal to 25. Then similarly, mod 2 a bar plus b bar is exactly 5. So this is very simple. No need of finding any a or any b. So simply we can use the direct formula for a bar plus b bar the whole square plus a bar minus b bar the whole square is what? Simply 2a square plus 2b square. We can use the formula and come back to find the answer. Now you come to question number 37. So it's a very simple problem. You know, 1 to 4 and 2 minus lambda minus 3 are initial and terminal points of the vector I plus 5j minus 7k. Then what about the value for that lambda? It's a very simple question. You know, initial point means I mark on OA. Vector OA is equal to I plus 2j plus 4k. And vector O is a terminal point is equal to 2i minus 3 lambda j minus 3k. So when you choose it as vector AB, then difference of that is I minus 3 lambda minus 2 into j plus minus 7k is there. this will be exactly same with our condition as I plus a 5j minus 7k. You can ignore the 7k and that take this 2. Then you can equate in this one minus 3 lambda minus 2 is exactly 5. So minus 3 lambda is equal to 7 or lambda is equal to minus 7 by 3. This is the answer of that problem. So option number 2. Now, question number 38. If the vectors PQ is equal to minus 3i plus 4j plus 4k and PR is equal to 5i minus 2j plus 4k are sides of a triangle PQ, then the length of the median through the point P. So here it is equal to a triangle P is there and a QR is there, PQR. So PQ is minus 3i plus 4j plus 4k and this is 5i minus 2j plus 4k. So this is the median if it is equal to S. Then how to find that PS? We already discussed that 2PS is equal to that PR plus PQ, sum of the two sides. So you can identify 5i minus 2j plus 4k plus minus 3i plus 4j plus 4k. Therefore, add this to you got at plus 2i plus 2j plus 8k. There is actually 2 vector PS. Therefore, PS is equal to I plus j plus 4k. This is actually one median through P. So, magnitude of a median PS is equal to square root of 1 plus 1 plus 16 is root 18, which is given there as option 4. Now question number 39. The volume of a parallelepiped whose coterminous edges are I minus j plus k, 2i minus 4j plus 5k and 3i minus 5j plus 3k. So if A bar, B bar, C bar are coterminous edges of a parallelepiped, then its volume is box ABC. So here volume is equal to determinant of the first one, that is equal to 1 minus 1 1 and 2 minus 4 5 and 3 minus 5 2. So we can find the answer directly by using the situation 4, adding this to this equal to 1 2 3 0 minus 2 minus 2 and subtracting that equal to 0 3 and minus 1. So, by simply I choose that C2 is tending to C2 plus C1, then this will become 0 and C3 is tending to C3 minus C2. So, you got that. Now, we can expand along the first column. That's equal to 1 into plus 2 minus minus 6 is equal to 8. So, 8 unit is the volume of the parallelepiped, which is option 4. Now, question number 40. Let x, y and z be distinct non-negative numbers if the vectors I plus k, xi plus xj plus zk and zi plus zj plus yk lie in a plane, then z. These 3 vectors are on a plane. That means they are coplanar. If lines are coplanar, then corresponding coefficients should be 0. So if the coplanarity will give you the condition there, 1 0 1, that is actually the questions of I plus k, and as x and z, that's the questions of this one, and z y. This is the coefficient determinant that should be 0 if the vectors are coplanar. If ABC are coplanar, then we can identify the box product or the determinant value framed out by them should be 0. Volume of the parallelepiped will provide the equation for that. So we can expanding this equation by 1 into, this 2, that is xy minus z square minus 0 plus 1 into this 2, that is equal to xz minus xz is equal to 0. So get cancelled, good as xy is equal to z square. So z is equal root of xy is actually geometrical mean between x and y. So, question number 40 option 3 is there. The geometric mean between x and y will be that of z. Now you come to question number 41. If A bar and B bar are two unit vectors and theta is the angle between them, then what is the mod A bar minus mod B bar? You know, mod A bar minus B bar the whole square is equal to A square plus B square minus 2AB cos theta by what? It is A dot B. Now, you know, this A and B are unit vectors. So 1 plus 1 minus 2 into 1 into 1 into cos theta is there. It is equal to 2 minus 2 cos theta. So you can choose that 2 into 1 minus cos theta be referred as it is equal to 2 into 2 sin square theta by 2. So that is actually mod A bar minus B bar the whole square. So, what is mod A bar minus B bar? Mod A bar minus B bar is equal to 2 sin theta by 2. So, 2 sin theta by 2 with the magnitude of A bar minus B bar in this problem. So, option 1 be the correct answer of it. Now, you come to question number 42. The position vectors ABC are given. Then the greatest angle of the triangle is there. There is a position, that is OA. Vector OA is equal to 1, 1, 1, and vector OB is equal to 1, 5, minus 1, and OC. These are the position vectors actually 2, 3, 5. Then, you know, if they frame a triangle, then we can find what is AB, vector AB. Vector AB is equal to this 2, you got that 0I plus a 4J minus 2k, that's vector AB, and BC, vector BC is equal to next 2, B and C is there, 1, 2 minus 1, that is equal to I minus 2J, 5 minus 1, that is plus 6k, and next CA, what is CA? So A minus C, that is equal to minus I minus 3, minus 2J minus 4k. These are the vectors. So, you know how to find the magnitude of AB. AB is equal to square root of 0 plus 16 plus 4. That is equal to root 20. And next BC. BC is equal to root of 1 plus 4 plus 36. So, root 41. And root of AC or CA, that's equal to square root of 1 plus 4 plus 16, that is equal to 21. So, among the three triangles, BC is the largest one. So, that opposite side be the highest angle. So, you can identify this expression there. What is AB square? AB square is equal to 20 and AC square is equal to 21. So the sum AB square plus AC square is equal to 41, which is equal to BC square. So definitely this is a right triangle with the angle at A is 90. So in a right triangle, maximum angle should be 90. So we can go that it is the right triangle be them. So the greatest angle should be 90 degree. So otherwise we can make the dot product of AB dot BC etc. We can identify one should be AB dot AC should be 0. So A is what? 90 degree. So the greatest angle corresponding to the problem is 90. Now we come back to question number 43. There is a mod A bar equal to mod B bar equal to mod C bar equal to 3. So mod A bar equal to mod B bar equal to 1 and mod C bar is equal to 3. B dot C is equal to minus 3 by 4. This question. Mod A bar, mod B bar are equal. Mod A bar is equal to 1 and mod B bar is equal to 1 and mod C bar is equal to 3. And B bar dot C bar is equal to minus 3 by 4. And A bar cross C bar is equal to 2 times A bar cross B bar. Then what is C bar minus 2B bar? So actually the second aspect is not need to find the answer of this C bar. Mod C bar minus 2B bar the whole square is equal to C square plus 4B square minus 4B bar dot C bar. So here given that C is equal to C square is equal to so 9 and B square is 1 so it is 4 minus 4 B dot C is equal to minus 3 by 4. So we can cancel this 2. Then you have the answer as 9 plus 4 plus 3 that is equal to 16. So mod C bar minus 2 B bar, the Oscar is equal to 16, or mod C bar minus 2 B bar is equal to 4. So answer of the required answer is actually 4. No need of the further information which is given, that they are the data which are misleading to find a different way or different answer or time constant. So you can easily find that mod C bar minus 2 bar by just to square the equation and convert it. Now, question number 44. The angle between A bar and B bar is pi by 6, and the projection of A bar in the direction of B is minus 6 by root 3. Then what is mod A bar? You know, this is actually B bar, and here I mark them as A bar. So if you mark this length is the projection, I mark this one as A, and here it is B and C. So this is the projectional length, and this angle is equal to pi by 3, which is given there. So, sorry, pi by 6. So, how to find the projection of a B bar on A bar? That is actually projection of A bar on B bar. Projection of A bar on B bar is equal to A bar dot B bar by mod B bar. So, it is equal to magnitude of A and that of B into cos theta divided by mod B is there. So definitely mod B we can cancel it. So it is equal to A cos pi by 6, which is given as minus 6 by 3. So you know the projection means it is actually negative. So no problem for it is minus 6. That should be on left side. So the angle is not exactly pi by 6. It is actually minus of pi by 6 is there. So no problem whether it is equating with the value as minus 6 by root 3. You can cancel the value from projectional number. Then you can find cos 60 is equal to A into root 3 by 2 is equal to 6 by root 3. Therefore, this implies A is equal to 12 divided by 3 is equal to 4. So the magnitude of A, definitely positive quantity, that should be 4, which is given option 4. Now you come to question number 45. The position vector of a point A and B with respect to O are 2i plus 2j plus k and 2a plus 4j plus 4k. Then what's the length of the internal bisector of angle BOA of triangle AOB? You know, in a triangle, if it is O, A and B, if it is A and B, then the angle bisector is here. Let's see. Angle bisector of a triangle divide the opposite side in the ratio of length of the other two sides. So here, first OA is given first side. So OA is equal to 2i plus 2j plus k. Then vector OA is equal to root of 4 plus 4 plus 1, that is equal to 3. Again, OB is our next side. That is equal to OB is equal to 2i plus 4j plus 4k. So mod vector OB is equal to root of 4 plus 16 plus 16. That is equal to 36 is that. So length of this side is 3 and that of this side is 6. That means this OC is the angle bisector. Divide that opposite side in the ratio of this 6 and 3. That is 3 by 6. 3 is to 6. This is exactly 1:2. So this is 1 unit and that is 2 units. This is 1 unit and here it is 2 units. So C divides internally in the ratio of AB in the ratio of 1:2. So we can identify C is equal to 1 into B plus 2 into A divided by 1 plus 2. Therefore, we can proceed here as that's equal to 1 times BB is our 2i plus 4j plus 4k is our vector B bar, and A bar is 2 times, that is 2 into 2i plus 2j plus k divided by 1 plus 2. So it is equal to 1 by 3 this into 2i plus 4j plus 4k plus 4i plus 4j plus 2k, which is equal to 1 by 3 into 2i and 4i, 6i plus 4j and 4k, that's equal to 8j, and 4k and this is equal to 6k. Therefore, that's actually OC. Now you want to find the magnitude of OC. Therefore, mod vector OC is equal to 1 by 3 into square root of 36 plus 64 plus 36. That's equal to root 136 divided by 3 is our second option. So now we come to question number 46 as our linear programming. They are very simple question. In linear programming problem, directly, a set of constraints are there and some objectives are given. And they are actually equations. So objective equation should be there along with some constraints. Then constraints are some linear equations and objectives also a linear equation. The pattern Z is equal to some a1x plus b1y plus c1 z like this, and some x y a z should be less than or like this. They are equations. So you simply draw the straight lines and identifying the inequality and observing the feasible region, and the corner points can be identified and put the optimizing by replacing the corner values inside. So here we have some simple questions. Question number 46. So here it is equal to the total number of constraints in a linear programming problem is always what? It is actually a finite number. Then only we are able to do that. Not less than or more than. That should be some finite number of equations should be given. Then the correct answer is there. So it's actually what? A direct question is this. Number of constraints in a linear programming problem is always a finite number. That may be less or more with our conditions. So there is no restriction for given only 3 or 4. So it should be a finite number is the correct answer for that problem. Now come to the next one. Which one of the following method can be used to solve linear programming problem? The first graphical method is actually there. And at the same time, solving procedure, analytical method is there. And there is a higher aspect, that is actually simplex method. So that's actually a complicated method. We can see in future whether it is a linear programming problem more than 2 variables, then it is very simple to step-by situation to solving it. So say a higher technique, that is actually simplex method. That means it may be can be solved by graphical procedure and analytical method and also simplex method. So all of them be the correct answer for this. So fourth option be the correct answer for it. Now we come to question number 48. 48th problem is which of the following techniques is used for solving linear programming problem by graphical method? So the answer, while you plot the entire equations inside them, the graphical procedure will provide some region. There's a feasible region is there, and you can put the corner methods inside them. That's actually corner point method can be sufficient to solve the equation. And ISO cost or ISO profit procedure is there. That's actually some equation there. We can identify loss inside there and after profit inside them, and their equilibrium point will give the maximum or minimum situation identified. So both 1 and 2 be the actual way to identifying it. It's also a theory part problem. We can observing them. 3 is the correct answer for that problem. Question number answer should be 3. Now the next problem is also, if at least one of the basic variable is 0, then LPP then the solution is said to be, if at least one of the basic variable is 0 is LPP, then the solution is said to be is actually degenerate basic solution. So you keep the situation framing the equation such as to introduce with different possible values of or the minimum values of the input variable should be exist inside up. Otherwise, it is very hard to identifying it. So minimum situation there x, y, etc. should be positive inside the condition. So that's actually we defined as what degenerating equation. We can easily identify this expression by simply go through the definitions which are relating with the linear programming situations or linear programming theories. So I come to the last problem. That's actually a feasible solution of a linear programming problem should be. What will be a feasible solution? That is actually optimize the objective function, it's actually satisfy all constraints and non-negative restrictions. There are some restrictions are given to you subject to the initial feasibility for x, y and z, etc. And at the same time, some constraints are given. So using the constraints, most of them are some inequalities. So identifying some inequalities inside them, you can identify a particular region corresponding to that. They are actually the feasible region for it. And the corner value will suggest to optimizing the situation, whether it is minimum or maximum. So that satisfying all constraints and non-negative restrictions will defined as the feasible solution for considering our linear programming problem. So I conclude today by advise you to read more in linear programming. They maybe usually come back to like this way to ask me questions. Thank you, dear all students.